In this session, we're going to demonstrate a data-driven app using Pyramid, and the example is going to cover risk analysis. Specifically, we're going to demonstrate how to use Pyramid's data modeling, machine learning, and analytical tools for calculating the chances of loan defaults for a classic commercial bank. The demonstration is going to use a lot of the capabilities of Pyramid out of the box without writing any specific code or having to compile any logic in other tools. To begin the process, we're going to start with the data prep stage 1. In this situation, we're using two data sets, a list of customers in an Excel spreadsheet, and all the facets around them, including different kinds of metadata, their personal details, and different metrics around the customer. Of course, this is real data, matched up with what is called bureau data, which is information around the loans made to these different customers, so we can understand historically what drives defaulting on a loan. The rest of the data flow or data prep tool that you're seeing here involves merging the different data sets in different ways, building a calculated column, converting a column, and ultimately punching out the whole data set to a temporary in-memory database that will be used by the data scientist to analyze the data and make decisions as to how best to construct the machine learning algorithm to predict the risk of loan default. Once the data model is run, which takes only a few minutes, data analyst starts to analyze the information. To demonstrate this, we're going to have a few reports that we use specifically in this exercise. Here we're looking at different metrics against the risk scoring, based again on the historical information, to better understand what metrics in the data set can be used as indicators of what drives loan defaults. In the next example, a similar analysis is done. Again, another set of scatter plots. Here we're plotting the propensity to be late on repayment of a loan against the amount of the loans on the y-axis versus the x-axis, and different facts and figures with regressions to determine the best way to construct our machine learning decision tree logic. This, of course, is just one example of the types of analysis that were performed by the data scientist. Post the exploration stage, we're now ready to begin the training exercise. The training exercise involves reading the same set of data again into the engine, and this time running it through the decision tree algorithm. You can see that the same set of data with the same manipulations is performed. This time, though, the result is not a database, but indeed it is a decision tree. The decision tree here is one of the curated plugins from Pyramid that can be used out of the box without writing any code. You simply choose the inputted columns and make some decisions around how the decision tree should be configured, and then train your model from there. The most important part here with curated logic is that you are not required to write any scripting or logic in Python and R, even though you can. An important stage is that the model is saved after the training, because once we have the definition of how to quantify a risky loan, we will apply that to the real data set in the prediction phase. Again, this can be run directly from Pyramid's data flow tools and can be quantified within a few minutes. After the training has been performed, we now take the training model and apply it to the full data set. Here we have an identical set of data flowing through. Obviously, it's the full listing of customers and all the bureau information related to them. There are a few more steps related to cleanup of the data, a few embellishments of the information with renaming features, random number generators and whatnot. These are all designed to keep it easy, and most importantly, us reusing the existing decision tree model that we created in the training stage previously and apply it to the data set, so that we can now predict per customer in this database whether they will or won't default on their given loan. Adding to this, we've got a k-means clustering algorithm in application, as well as an EMD clustering. EMD is very good for clustering non-numerical data. K-means is specifically for numerical data only. Both of these are going to be added and tacked onto the data set for further analysis. You can see as well that the data scientist has an option to include Python and R scripts, and even SAS if it's licensed, but has not been needed in this regard, since the plug-and-play widgets out of Pyramid's data flow are sufficient. In this example, the data scientist can now trigger the prediction data flow, after which he can take the result set and begin the analysis. The easiest ones to digest are some KPIs, which show how the prediction engine has quantified the risk of default by year from 2017 to 2018 to 2019, and you can see that it is steadily growing. In this situation, the bank has decided that anything less than 7% is acceptable, 8 to 10 is okay, and above 10 is bad news for whatever reason. Why Pyramid kicks in at this point is to give you drag and drop, slice and dice experience to better understand who, what, where and why the risk has changed. So for example, using gender, I can instantly slice and dice these KPIs to get a better sense of what's driving this. And you can clearly see here that the female track on the top is doing better than the male track on the bottom. And in fact, this might be a great indicator of what kind of customers this bank should loan to versus not loan to. As another example, we can use family status to break out the KPIs as another attempt to understand the risk. And so the process continues, with Pyramid giving the data scientist a simple, elegant, fast drag and drop interface for analyzing, deconstructing, and searching for the reasons for the high rates of default versus the low rates of default on the bank's book of loans. The last chart we're going to show is a full-blown trend bringing together all the facets of the analysis. You can see here the solid blue bars being the amount of credit the bank is offering to its customers, in other words, the portfolio of loans, and you can see how it has been trending up month by month since the beginning of 2017. You can also see, using the forecasting tools in Pyramid, the projection of this loan cycle as it moves by month, and how it's expected to grow. Applying a regression to this set of numbers in blue, the blue line is showing that the actual growth in forecasts statistically over time is going up at a comfortable rate. Interestingly enough, we can see with the red bars the predicted loss on each of these loans over time, and you can see that's also going up and growing, and you can see that the forecasting engine is also predicting that to go up over time as well. Interestingly, the predicted losses, which are calculated by applying the predicted failure rate against the entire book of business projected here in blue, is going up at a slower rate than the book of business itself, which may be a good thing in the end. The last thing that is very fascinating in this chart is the black line. The black line is the predicted rate of default for the book of business for this bank, and that has been generated by a decision tree algorithm, and it's obviously projecting that for all the time since 2017 up to the end of 2019, and you can see that it's moving up. This is then forecasted further out into the future using the forecasting algorithm. We can also see the prediction interval there in the light shaded gray to show you the range of this forecast. And overall, what we can say is that that rate is also going up at a steady pace, which should be worrying to most bank managers. Of course, this also explains why the loss ratio is increasing. And it is something that needs to be analyzed to work out how to get these issues under control. Obviously, you'd like this to either be static, flat, or going down. This is a great demonstration of how Pyramid is able to bring all the facets of advanced data analytics to the business and data science users through the data prep process, machine learning, both training and prediction, and finally with analysis of the results.